Welcome to this talk. In this talk, we want to talk about, is there a choice when it comes to facing air pollution? My name is Alexis Lau. I'm the project coordinator of this PRAISE Hong Kong project. I'm also the head and chair professor of the Division of Environment and Sustainability and director of the Institute for the Environment at the Hong Kong University of Science and Technology. Why do we ask the question? Because there's a lot of public perception that when air quality is not good, we have to go on with our life and there's not much we can do about it. I want to use this talk to change this public perception. Why do we have this perception? This is an example of air quality variation shown in Hong Kong. It's a relatively old map, but the situation haven't really changed that much. It shows a number of air quality monitoring stations around Hong Kong. We now have 18, but it is enough to show the air quality variation average over a district. But right at your location, it can't show. For example, here, what you see is overall, most of the place air quality is between low and moderate. Everywhere is similar. But if you think about Hong Kong's topography, you have a lot of buildings, a lot of places where are blocked by streets, and there's a lot of cars moving around. So the emission from the car may not be able to disperse properly. And we have done some experiment driving throughout the street and measure the NO2 concentration. And you can see from here, there's actually a lot of variability in the district. The existing network cannot really tell. Because we don't know that there is a lot of variation, there's actually not much we can think about doing if we have an air pollution episode. This project is called the Personalized Real-Time Air Quality Informatics System for Exposure. It's built for Hong Kong, so it's called PRAISE Hong Kong. Our idea is to empower the public with highly personalized air quality information so that they can help themselves to reduce the pollution exposure and reduce the associated health effects. This project is sponsored by the Hong Kong HSBC 150th Anniversary Charity Program. We have a very large team on this project looking at different things from the dynamical transport modeling, ultra-high resolution atmospheric modeling, big data, smart sensor, mobile technology, all the way to public exposure as well as health effects. What is this PRAISE system? It's built, first of all, through a very detailed understanding of Hong Kong's regional emission inventory. Basically, what are the emission sources? How is their characteristic of emission? Then, by knowing where the pollution get out, we need to understand how the atmospheric circulation brings it around from one place to another. Okay, so to do that, we have to have also a regional meteorological forecast. This is done by our regional air quality forecast system. And this, because it's regional, actually, if you think about what is the wind, what will be the wind in the next few days, you know that this actually can be very variable from one day to another. So we need a system that can simulate the weather variation for many days so that by the time the system comes to Hong Kong, we can accurately predict it. So it is built with this numerical weather prediction system. But this system, the scale is very large. Typically, if we look at regional air quality monitoring station, the smallest so-called grid size is about 1 kilometer. That means the resolution is very coarse, and you cannot tell what is happening in between 1 kilometer. So that's not useful for me because I want to know much more detail in terms of the resolution. So we also have something called an urban air quality forecasting system, which by merging in what the building look like, how the traffic happens in the city, we can give a more detailed analysis. This is our ADMS urban modeling system, okay? And then with all this, we will have a 48-hour forecast as well as a very detailed analysis of the air quality at any time when we want the data. But a lot of time, because the traffic that is currently available in our model, because it takes quite some time for us to run this model, what is happening in real time in traffic is not in our model. So our model cannot take into account of this type of changes. So now with real-time traffic, real-time weather, real-time air quality data, we can use this real-time data to modify and correct the bias or the difference between what is the current situation compared with what is the measured situation. And this greatly increased the accuracy of our model, as I will show shortly. Okay, so we have this big data analytics, which helps to improve our the accuracy of our model. Okay, so when we combine, what you can see in this map is a very detailed, you can even see something like the blood vessel of a body, or these are actually the streets of Hong Kong, okay? Once we have this, then we can use different methods to disseminate this to people so that they can use it for their own work. I talk about the importance or the high level of information. Let me just give you an example. This is a 3 kilometer by 3 kilometer area in Hong Kong, near what we call the Kowloon Wan district, okay? So in terms of air quality monitoring station, we have one single air quality monitoring station. This is one of the 18 monitoring stations available in Hong Kong. So within this 3 kilometer by 3 kilometer grid, there's only one air quality monitoring station. But you can see the shaded area here are actually the buildings. If you imagine some of these buildings are very tall, as we saw in the earlier figure. So you would expect the air quality at this location may not be the same as other places. So if you just use this particular point as a reflection of the air quality variation, that may not be enough. So we use model. The more common model, as I talked earlier, is this regional air quality model, which is called CMAQ here. The CMAQ resolution is 1 kilometer by 1 kilometer. And if you look at this, now we have, instead of one single point, we have 16 points to describe the variation of air quality within this region. But again, you can see that none of our building is 1 kilometer wide. So the variation that is within the grid cannot be represented by this CMAQ resolution. So that's why we need another map, which is the ADMS urban grid. This ADMS urban grid is one that we work with the researcher, so that when there's road, we put a lot more grid point there, and when there's less variation, we don't put in that many grids. So this is an adaptive grid with the maximum resolution down to 2 meter by 2 meter resolution, okay? So when there is more traffic or the road is narrower, we actually increase the resolution. Okay, and you can see from here, now we can start seeing at different locations, the number of points is different, as well as this is a simulation of the NO2 variation at a particular time. And you can see among this road, some of the place has much higher resolution, much higher NO2 concentration. So if we map back our old building there, you can see from this particular map that, oh, now you can see that at different locations, the air quality is different. And this is the NO2 variation. Some of the roads which has much more traffic, the NO2 concentration actually is much higher as compared to some other place when there's much less traffic or no traffic going to that location. Then the NO2 is mainly go there by dispersion and the level is lower. Okay, so this is something we can do using certain emission. But again, as I mentioned earlier, if at a particularly road there is traffic congestion, that traffic congestion was not originally in our emission inventory, so we cannot predict that. So what we have to do is to add this with the real-time information. So the real-time information can tell us more about the traffic variation as well as how it affects the air quality. Okay. So with all this, what is the accuracy? This is the example of our system. Here, what is plotted is the percentage AR or the percentage health risk, short-term health risk at the central air quality monitoring station, which is a roadside station. And you can see that what is plotted here, the dots are the observation, and then the green line is our regional model. The yellow line or the orange line is the after ADMS, the urban model. Then finally, the blue line is after we correct it with the real-time observation, the PRAISE-Hong Kong system. So you can see, compare with the observation, the lowest resolution CMAP model does not capture a lot of the variation in the streets. But even when you capture it, sometimes the orange line map varies quite well with the red dot, saying that the ADMS is performing well. But there are also situations when the ADMS may not do as well as the, there's still some bias. So our PRAISE system can adjust in real time and get a much better forecast. So you can see from this, the original index of agreement was 0.74 using the CMAP model. With the ADMS, the IOA increased to 0.84. And then with PRAISE-Hong Kong, the IOA actually get to a very impressive value of 0.96. Okay. So this is for the central station. Another figure here we have for the another station. The first figure is for 2019 May. The next one is for a year later, 2020. And actually, we have some statistics for longer term. This is the statistic from 2019, the first 3 months, all the way to 2020, the last July, August, and September. And you can see from here, the blue area, which is indicated by the PRAISE-Hong Kong, actually the index of agreement always lies above 90, and then much better than the CMAC or the urban ADMS. Okay. So all this is already being placed in a website which we call Praise Hong Kong. You can actually go to the App Store and then download the Praise Hong Kong app, and you can get the information about air quality around you. Okay. So in terms of function, this Praise Hong Kong, what we call Phase 1 app, give you what is the street level air quality. It also allows you to bookmark some place where if you want to know a particular location, like your parents' home, you want to know what is the air quality variation, you can do that. And then it also, because the Praise Hong Kong has the forecast capability, you can set certain threshold. When the air quality is over a certain value, then the alert will be sent to you so that you can inform your parents or your family so that they may close the window or do other things to help protect themselves. Okay, so this is a alert system that can be done to help the loved ones. We can also have other things, but this is the first phase of our PRAISE project. After this phase, we actually start asking the question. When we start, we talk about, okay, during a day, we don't know where do we get most exposure from air pollution. Here, we can actually track a person if they allow us to track them, because we can use the mobile phone to track where they are, and then also use our system to understand at their location what is the air quality. Okay, but you may ask, most people don't stay outdoor. Your system can only simulate what is outside in terms of air quality. That's true. So actually, we spend a lot of effort trying to understand the relationship between outdoor air quality and indoor air quality. Okay, and then by understanding that, we can understand the exposure of a person as they move along different time of day. What are the exposure they are subjected to, but in different microenvironments. Okay, so you can see in our system, we basically use mobile tracking to understand where the person is, and then by understanding the relationship between outdoor air quality and indoor air quality in different microenvironments, we can add up the exposure estimate of a person. To do this, we actually spent 2-3 years of effort going into different home, school, office, different transport locations to make a lot of measurements. This measurement, we actually take into account of a lot of the characteristics, like when this home was built, how large they are, what is the building type, do they use air conditioning, what type of air conditioning, as well as any use of air purifier, what is their habit. So all these parameters we look at, okay? So we have visited something like about 51 homes, 32 schools. Again, for schools, we look at different build year as well as different districts. So we actually have done a very comprehensive analysis of collection of data. And for each of these schools, what we did is one warm summer, basically one summer measurement as one winter measurement. Each of that for a week, so that we have good measurement that is representative. Okay, so For example, school is very important. What we did is we bring in equipment like this, okay? Some of these are outdoor measurements, which can be fixed. You can see these are much more rigid, so they can be put into the outdoor. And then we also have some which we can carry around, but with the more or less similar or equipment, okay? So this one actually, we carry it around all the time during this experimental period. And these are the portable air sampler. More recently, we have downsized the monitor, changed from this 15 kilogram equipment into this about 2 kilogram, which we can carry around much easier. And they measure all the air quality as well as temperature, humidity, pressure information. These are the schools that we have looked at. If you look at this, you can see that we try to spread it out so that we have better understanding of the school distribution. This is the home distribution. We have 51 homes all around. Again, this is spread out in different parts of Hong Kong so that we have a better understanding of different distribution. When we go into a home, what we do is to set up the outdoor air quality somewhere outside, and then find a place in the center of the home to measure what is the relationship. Basically, we want to understand what is the relationship between indoor and outdoor, okay? Other than homes, we also went to look at office, because people spend a lot of time in their office. So for this, we have went to a number of different sites making the measurement. And this, depending on different place, we have different type of ventilation, okay? A lot of people think that most of their exposure is from traffic. And traffic is actually very difficult to measure. So we have spent a lot of time looking at different traffic modes. Like, for example, for this particular measurement, we actually gather all this team. We have 9 MTR lines, and we, on each of these days, we go into one line and make very detailed measurement, as well as there's once we actually go spread it out so that we make measurement comparing what happened across the line, as well as look at details within a line. And within this measurement, we actually measure inside the MTR trains, as well as outside on the platform, okay? Other than MTR, we actually also measure within the bus, minibus, trams, as well as the transport location. So after we make all this measurement, we categorize the data according to different microenvironment, as well as the parameter we think that the indoor air quality will be dependent on, like whether windows are open, whether the ventilation is powered on, and so on, okay? With that, we actually do statistics to try to understand how the infiltration factor change with different microenvironment setting. Like, for example, this is when we look at the infiltration estimate for home, okay? We look at PM 2.5. When the home open their window, then what we find from our study is that the infiltration of the PM 2.5 can be quite high, okay? With a mean infiltration factor of 0.83 and then the standard deviation of 0.03, okay, when we open the window. If we close the window, what we find is that the penetration dropped by 0.11, meaning it dropped to the infiltration factor of 0.72, and the standard deviation increased. Okay, so if we know that people close the window, then we can use a infiltration factor of 0.72. If we know that the person is opening the window, we can have a infiltration factor of 0.83. Okay. Besides the window, we can have air conditioning, whether they turn on the air conditioning or not, or whether they turn on the purifier or not. So we can have all this number, and this is not just for PM 2.5. We can actually have it for PM 10. We can look at NO2 ozone. So with this measurement, we can actually know for people in Hong Kong, if they go home and they use different combination of window, air conditioning, and air purifier, what is the statistically measured infiltration factor for the different pollutants? Okay.
A new second phase PRAISE-HK has been placed on the Android and Apple App Store. If you want to get this, you can search for the PRAISE Hong Kong EXP app. Actually, to help people, particularly who are not in Hong Kong, to understand a little bit better about the PRAISE app, we actually have created a web-based website. This is the http praise-web.ust.hk. And we also have created some demo accounts for people who are not in Hong Kong. They can use this demo account to log into the program and see the capability. Okay, in the first PRAISE app, which we give very detailed, personalized air quality information for anyone within Hong Kong. In the second phase app, which we introduce the exposure capability, we can follow a person with their permission and then tell them how much exposure to air pollution they have over a day. For example, this is the record of a person 24 hours. We can follow them in the morning from the time they sleep to the time they get up and leave home. After they leave home, we can tell whether they're in their office or they are traveling or they go to another place. Each of this, we use the infiltration factor that we estimated from the earlier study, and then identify what is the percentage infiltration, and then because we know the outside air quality, we can then tell what is the concentration of different pollutants in the respective microenvironment, and then we can provide the sum. Okay, so this is a breakdown of the exposure of the person as they go around in the day. Okay, finally, we can also use this to summarize for the person what is the overall exposure on different days. And then if they use the app, there is also a symptom report function, which they can say, okay, what is the symptom if they have some symptom on a particular day. Okay, so this has a record for them to say, oh, whether air pollution exposure is related to any symptom they have. Besides this, we also use the app to try to understand the detailed exposure of different groups of people using the census data. So we created artificial diary from the census of retired person, homemaker, driver, outdoor worker, as well as office worker. Okay, so here we are looking at, like in this example, a retired person. In the morning, according to the census, people will stay home, and then in the morning they go out to do some light exercise, and then afterwards they go home and take a rest, and then they may go out to have a walk or go to meet their friends, and then have lunch, and after lunch they buy some grocery and then go back home. Okay, so this is a diary that is quite common according to our analysis of census data. Okay, so what we have done is get some of our researchers to follow this pattern. We have a few researchers going around, follow the same pattern, and then we look at how the exposure of such person is calculated. Okay, so this is an example of a retired person, and here what is shown here is really the exposure according to 4 different calculations. Number one is the AQMS. The AQMS is the nearby AQMS as reported by the EPD. If we use the concentration of the most near air quality monitoring station, the exposure will be given by the blue line. And then if we use the PRAISE outdoor, we will have the purple line. And then if we use the PRAISE indoor, which is the estimation using a combination of the PRAISE outdoor multiplied by the factor, the infiltration factor, we will get the red line. And then finally, we have the PEK, which is the small sensor which we have. And we can use this to follow the person and then calculate what is the exposure. And you can see this is the green line. If we trust the PEK sensor, then what we have is basically a comparison of the PRAISE indoor, which is the PRAISE-HK calculation, with the actual measurement, the green line in terms of the PEK. Here is this example when the person really retired person stay home and then go out for a walk and then come back home and then go out. So this is the icon as well as the color differentiate where the person is different time. And then we calculate first the exposure concentration of different pollutants. And from different pollutants, we can estimate for them in terms of the percentage AR for that particular pollutant. And then we can add up all the pollutants in terms of total by different person. This is the bus driver. This is an outdoor worker, a retired person, a outdoor or a office worker. So again, this is the combination of the percentage AR. The earlier one is just the PM. Again, the focus is how good is the comparison between the red line and the green line. This gives us capability of really looking at how much time they spend on the day. So how much exposure are from different pollutants, different mode or different microenvironment. So for example, we've done this preliminary analysis. We have done 3 days of measurement. And if we use the nearest AQMS, the unit is actually in percentage AR day. And if we use the nearest AQMS, the exposure unit is 3.82. And then if we use the actual location, this person probably is more close to the road, so their estimated exposure infiltration is 5.40. And if we use the infiltration factor, then the calculation gives us around 3.838. And then according to PRAISE, which is our own measurement, this is 3.08. So we can do this for other parameters, and you can see that numbers like here. These are different dates, so we cannot compare across for different exposure. But if we look at PEK as the reference value, then we can see that the PRAISE indoor app or PRAISE exposure app give an estimate that is within 10 to 15% of the PEK measurement. This is actually a very good comparison. Certainly, this is only a small number of measurements, but it is a very good example of how we can actually get some estimation from the PRAISE exposure app. In particular, we want to go into this my exposure example. Let's look at a full day. This is a very simple day, but trying to do it to illustrate an example. This is a day when, okay, in the morning, from midnight to around 10 o'clock, the person stay home and then goes back to the office, spend for a couple of hours up to from 10 to 7 p.m. and then afterwards walk back home. So we only see two types of exposure here. What you can see is the total exposure at home is at 42 units, and then in the office is 19. So this shows the person actually managing the air quality in home is more important than managing the air quality in the office. Actually, for a lot of people, we have gone through this building and looked at people's home. What we find is that in most of the office environment, there are some type of air quality management system, like some filter as well as some ventilation control, which lowers the pollutant concentration, particularly with respect to like particulate. So in terms of their particulate concentration, office are typically better than people's home. And the other factor is that people spend much more time at home as compared to they spend in the office. So the total exposure in the home are higher than the exposure in the office, okay? Like for example, in here, we can actually look at the distribution, and we can even change, okay? If we try to change the microenvironment setting, we can click onto the home button here, and then it will analyze and give me a setting which is the default. Okay, here like in my case, I open up the window, but I did not use air conditioning or any air purification system. Okay, if we just click the first part, we can actually talk about what is the calculation when I use this type of microenvironment setting. But I can actually change it. I can actually say, okay, if I had closed the window, turn on the air conditioning or the air purifier, what would be the resultant change in exposure? Okay, so we can click and edit this. We can close the window. Like this particular example, we use the air conditioner, we use the microfilter of air purifier, and then we save the setting. After we save the setting, what we get is that the concentration here become lower. This is actually quite similar to the setting of most office areas. So you can see a immediate drop of this part of the exposure. And if I do it the same for both the morning and night, so the air pollution exposure for me could have dropped from 42 units to 27 units, which is a significant reduction compared with the original exposure. Okay, so by just managing our home environment, we have reduced 25% of our total exposure to air pollution. So this is a significant difference. If we are doing this during the episode day, this can significantly reduce our exposure to air pollution. Okay, we work quite a bit with Asthma Society because asthma patients are quite sensitive to air pollution. So we have been working with them and introduced the app to Asthma Society. And Asthma Society has helped us to tell their members how to best use our app in terms of planning the day. So another engagement is with Blue Sky company, which they give estimated location of air quality at different locations. We have a application interface, an API, which they can directly look into our database and then use it as the estimate of the air pollution at a specific location. Okay. We also work with the EKEO, Hong Kong's Energizing Kowloon East office. This is the office of the Development Bureau, and then we have an app which they can talk about the air quality at a particular location. Finally, we also work with the Environment Bureau, and in the 2021 in the Clean Air Plan, they actually talk about potentially building a system very similar to ours so that people will continue to have this high level, very detailed air quality information that people can use. Finally, what we want is if people think about this as a weather app, which a lot of people do in the morning when they go out. Before they go out, they want to check, okay, do I need to bring an umbrella today if there is any chance of rain? What we want people to do is to be able to just, before they go out, they may actually say, okay, let me check what is the air forecast for today. If the air forecast is okay, we actually think that it's good for them to open the window, because opening the window actually allows fresh air in, and because sometimes the air pollutant accumulated inside the home can also be a problem. So we don't think that it is good for people to just close their window all the time. But if the day is forecast to be good, then open the window. We probably encourage people to do more outdoor exercise. So we can look at this in the morning. And then if a day that it is forecast, the air quality is could be worse later part of the day, then before they go out to work, they can close the window, maybe even switch on the air purifier and air conditioning to help reduce the air pollutant in the room. And they can even call their parents or other people they care about to ask them if they themselves would not be able to check the air pollution. Okay, so this is a very simple use of the app, but it should be able to help people reduce their exposure to air pollutant quite significantly. In this work, actually what we find is that during the time of COVID, it actually is pretty difficult. But the COVID also gives us some help in terms of people actually understand ventilation and indoor air quality is important, which is our highlight in this particular project. So COVID both delayed our project as well as highlighting the importance of indoor air quality. So we think this is important. From our overall thing, this is an advance in terms of the control, in terms of management of air quality. Before the 1970s, we have this what we call source control, which is managing what is out there in the emission. But with the 1970 Clean Air Act, the management is really on concentration. We estimate what is not good in terms of concentration, and then the air quality standard manage it in such a way that the outdoor concentration is lower. We still keep part of the emission source control, like we are talking about in terms of vehicle. We look at the emission. Finally, I think we need to also talk about exposure and health risks. So now with smart city, we think it's important to go down to individual exposure. Okay. Finally, we want to take this opportunity to thank the HSBC 150th Anniversary Charity Program, which is the sponsor of our project. Without this sponsorship, it would not be possible to have such a big integrated team working on it. We also want to thank our local and international science advisors, the supporting organization and strategic partners, supporting like different parts of the project, including the modeling, the emission estimate, the exposure measurement, is a combination of different people, and then finally the project team. So for this, I would refer to our website for more information. So this is where you can find different description of the project, and thanks a lot for your attention for this presentation.